A tutorial about gravitational potential energy. An object at any height has the potential to fall. This potential energy is called gravitational potential energy. If the object falls, then this gravitational potential energy will be transferred to other forms of energy, like kinetic energy and possibly heat energy if there's any air resistance. To calculate gravitational potential energy, we can go back to the work equals force times distance equation. We use the symbol E with a subscript P for gravitational potential energy, so we'll replace the W with that. Force, that's the weight of the object, so that's m times g, and the distance this time is the height. So we end up with that equation. EP, or E subscript P, equals mgh. So we'll take the mass in kilograms, multiply by the acceleration due to gravity, which is 10 meters per second squared, and multiply by the height in meters. Now just a note about height. You're actually calculating the gravitational potential energy between 2 points. H does not refer to the height above the ground. It refers to the vertical distance between 2 points. So in this example, if the question related to the creature jumping to the first step, then you use 6 meters, not 8. What if it jumped between those two lower steps? Then your H would be 2 meters, because that's the difference in height between the two. 8 take away 6 is 2. Is there ever a height 0 meters? Is that at sea level? What if you dig a hole at that point? Well, if you dig a hole, you can fall into the hole, which means that you still have gravitational potential energy. So how deep must the hole be before you stop falling into it? That's an interesting question. So what does this mean? This means that when we're working out gravitational potential energy, we are working out the difference or change in potential energy between 2 points. So the formula that we should use, and you must use, is delta E equals mgh. The delta stands for change in. So this reads the change in gravitational potential energy equals mass times gravity times the height. Now if we look at a triangle, I've left out the delta here just to avoid confusion. The triangle looks a bit strange, but it's quite easy to use. If you want the gravitational potential energy, you cover the E and you're left with mgh. If you want the mass, cover the m and you're left with E divided by gh. And the height, E divided by mg. We don't have to worry about a formula for g, because g is always the same. A 40-kilogram boy is 8 meters above his landing position, so the height is 8. What is his gravitational potential energy at that point? Well, the formula, substitute the values, and you end up with 3,200, and the unit is joules again, capital J. A skydiver falls a vertical distance of 50 meters. How much gravitational potential energy was lost in this time? See if you can work that out. So the formula again, substitute the values, and you get an answer of 45,000 joules. Now whenever you see something like lost in inverted commas, you know there's another question coming up. So the other part of question 2 might be, has this energy been lost? Explain. What do you think? Well, the answer would be no, the energy has not been lost. The gravitational potential energy would have been transferred to other forms of energy, like the kinetic energy of motion, because the skydiver might be getting faster, and heat energy due to the air resistance or air friction.